This is DevOps in Agile Way podcast.
Hello everyone. This episode will be a little bit different because I'm recording it not in my own, let's call it boldly studio, but I'm using like a mobile microphone set called Saramonic Blink 500 Pro, which I really like, but I never use it to record the podcast episode. So we'll see what will be the quality of this recording. I have no idea really. Today I'd like to go with you in some kind of live walkthrough report, which was published quite a long time ago, because in January of this year, January 2023, but still I believe it has its own value, and this is interesting to go through it. Report is called State of the Infrastructure as Code, and it's done by Firefly. Why I believe this report is important to go through? Well, first of all, because I'm really interested in infrastructure as code. I am, let's say, professionally involved in this. As you follow me on LinkedIn or different socials, you know why. And also, this is very, very important and significant part of the DevOps workload, DevOps work and DevOps approach to the business. So, first element which I want to mention from this report, by the way, this report is really, really cool, and I really encourage everyone to go there and go through this report, especially if you work with infrastructure as code, or even more especially if you think to enter this world of the automated and codified infrastructure. So you can find this report on gofirefly.io. The first thing which we learn, that infrastructure as code is on the rise. This is the first slide, and it is quite obvious, I would say, but this rise is bigger and bigger, so that is promising. What hits me on the beginning is the second number in this report. It's 90%. What 90%? So 90% of cloud users who were surveyed by this report, 90% of them are using infrastructure as code. What it means, if you think like me some time ago, that we are not kind of avant-garde, but the standard. We do infrastructure as code, we do CI/CD, we do this, we do that, and everyone around is doing that. No, the fact is that we are living in some kind of bubble, and this bubble has very, very thick borders, and we do not see the reality behind that. And our bubble is quite small, so it doesn't matter how many users they surveyed. Well, they are not able to survey like 50% of companies around the world, right? To make this simple, if 10 users answer to the survey, 9 of them are using infrastructure as code. But there is 1,000 other people which didn't answer to the survey. And it doesn't work that way, that from this 1,000 people, 900 will use infrastructure as code. No. They probably are even not aware of existence. Some of them, of course. If we go there, the numbers will be like 40% or something like that. Because who answer to this kind of surveys? People who at least know about this technology, at least know that this kind of approach exists. This is quite important. And also, for the business value of the infrastructure as code, the third number in this report is $3.5 billion, right? So $3.5 billion. This is the projected value of the infrastructure as code market in 2030. So we have still, like right now, we have six years and a couple of months to reach this. It is quite interesting to see that. What are the problems? What are the findings related to problems about the infrastructure as code and around infrastructure as code? It isn't surprising for me. So manual labor is one of them. Second is shortage in qualified talent. Third, configuration drifts. And fourth, fragmented tools. And yeah, that is truth. And all of them are quite connected, I would say, okay? Because what we can see is connection between, for example, manual labor, manual work with shortage in qualified talents. And if we do not have proper talents, we very quickly will hit drifts. Those kind of not very well qualified. I don't want to be like, I don't want to judge these people, because I truly believe that all of us do whatever we can to do our work, our job as best as we can. Okay? So this is very important. And fragmented tools. This is very interesting, because not that long time ago, I started to look deeper and closer into infrastructure as code and the approach to infrastructure as code. And I can sign myself under the statement that in infrastructure as code, we have fragmented tools. Because how we do infrastructure as code, how we work with infrastructure as code, we try to work right now. We try to work with infrastructure as code in very, very similar way like we work with the code of the application. But those two things are totally different. We do not work with databases in the same way like we work with code of the application. There are differences, significant differences. And in DevOps world, if you were watching what's going on, we had issues with the DevOps approach to databases for many, many years. And right now we have, let's say, specialized ways of working with databases, but it is not exactly the same like for the code. Of course, we have different layers, different approaches to work with database from the code, etc. Doesn't matter at this point. We talk about infrastructure as code. So what we do? We put our template, Terraform, OpenTofu, CloudFormation, RM, whatever, to repository. And then on top of this repository, we trigger CI/CD pipeline. It came to my mind that this is tricky, because if CI/CD pipeline works very well for the application, because it was designed for this, right? To deliver application code from VCS, so version control system, to like target environment or environments, and that's it. If we deploy new version of the container, we don't really care, or let me say this differently, the pipeline doesn't really care what is the state of this container right now on the environment. It is running, it is failed, it is there at all, it doesn't matter. That's why somehow we present CI/CD pipeline as a line. It starts somewhere, it ends somewhere. It takes what is there and ends with anything what can happen. With infrastructure, however, it is a little bit different, because the infrastructure is there, or it's not, but well, you know what I mean. And any change to the existing infrastructure means some kind of, let me say it this way, some kind of interruption of current state. That is why the pipeline for the infrastructure should have some awareness of the state. That is why, for example, with OpenTofu or Terraform, we have the state file and we need to operate on the state file, right? So when you run Terraform apply or Tofu apply, what you do first is to do the diff, let me call it this way, do the diff between the existing state, existing infrastructure, and changes in the template. But in standard CI/CD, you need to do it additionally. There are tools where you can orchestrate the infrastructure as code. The tools are the next level of CI/CD with focus on infrastructure. And those tools are not only just the CI/CD tools or pipeline tools, but also the orchestration and management for the infrastructure tools. One of them is the Spacelift, right? So you can go to spacelift.io and see what is there, how it works, and what is possible with this tool. I encourage you to do that. Now, let's come back to our report. So this fragmentation is a real problem because we do not have complex control over the collaboration, over the pipelines, and over the management later. And in this management later, I mean also the drift detection, which is quite important. What is drift detection? Well, this term is telling us about the discrepancies between expected state of the infrastructure, and the expected state is what is in the state file of OpenTofu or Terraform, or the templates of the infrastructure, and actual infrastructure which is in the environment. How those discrepancies can happen? Well, there is always someone who has admin rights. This kind of person can go into the AWS, Azure, GCP, whatever, and do some changes manually in security groups, in the databases, in the scaling groups, whatever. And this leads to differences between templates and actual infrastructure, and this is the drift. So what we should do is to limit this drift as much as possible. Let's go to some more positive slide, so about the benefits of the infrastructure as code. The Firefly team found like 4 operational benefits. The first is engineering efficiency, second, less downtime, third, easier audit and compliance, and fourth, faster troubleshooting. This is true as long as you have proper process. This is also important to mention, because without proper process, not much will change. And honestly speaking, there will be more problems than benefits, really. Let's go to some other element. Oh, this is quite interesting about the cloud governance. And they found like drift identification is poor for most or not addressed. And this is very sad. And the number here is 61. 61% of the people who respond to this survey said that they cannot detect configuration drift or do this manually. And again, that is why there are tools for it. We have a lot of tools out there which can help you automatically detect and even fix drifts. It's not that hard to implement them. In my opinion, this is my personal opinion, why people are not doing it. It's not because they lack knowledge about the tools, etc., because this is easy to solve. Go to your browser, enter into the search bar in Google, drift detection automation tool, and you will have the list of the tools out there. The problem is that we are mentally not ready for this. Because automation, yes, but automation on, let's say, our rules. We are afraid to have automation which will do things without our approval, even knowledge. And automated drift detection and remediation will work exactly in this way, okay? So if some user, let's call him John, goes to AWS and change the security group and open SSH to whole world just for a minute, he did it because he had very good reason for that, right? And well, it's a little bit sad that he forgot it and we had this SSH open for 2 weeks already and couple of attempts of attack, but he had a reason. So we shouldn't do any automated action to fix this problem because it's not the problem. And this is the wrong thinking. The general rule is that this John shouldn't have any possibility to have like a admin access to production or whatever account. And if the change happened, this change is not expected, this change is not authorized really by the process and should be reverted as quickly as possible. That's why drift detection should happen as fast as it can, and then remediation automatically applied. And John will be not able anymore to log from Canary Island or wherever he is right now. I'm sorry, but that is how it should work. And that's why like 35% of people are spending days or weeks remediating drift, if they found this drift at all. So, automated tools for drift detection and automated tools for drift remediation. That's the answer. That's the only one answer. Okay? Interestingly, this is quite interesting and I didn't expect that. When I look on the another section of this report, it is data about multi-cloud. Not that many users are using single cloud. Most of the users are using multi-cloud. And that is interesting because, for example, 23% of the people who respond to the survey are using AWS alone, but 61% of people who are using AWS mainly are using also another cloud. This gives us the picture that multi-cloud is quite interesting choice for many companies, and the reason for that are quite simple. First of all, we want to have some kind of, let's say, false idea of disaster recovery. Okay, why it is false? Because even in single cloud, we do not have one point of failure. Probably I will do the episode about this in some future, but for now, this is important to understand. If something happening in AWS, Azure, GCP, and your service is not available, this is something big, and it doesn't happen that often. It happens, yes, but not that often. So you need to reevaluate probably your DR approach if you want to have DR in another cloud. What are the reasonable reasons of choosing multi-cloud? So giving yourself the flexibility, not being vendor locked. We had a discussion with one of my guests about vendor lock, and vendor lock is not that bad. We shouldn't demonize it it's not the worst devil in the world. We need to be reasonable about this. But let's say having more vendors will give us easier escape path if we want to change something. Also, the clouds are different, the vendors are different, and that's good. So we can use this kind of multi-cloud setup, right? So for example, in one of my previous company, we were using one service from GCP while the whole workload was done on AWS, and that's fine. I didn't expect that I will talk so long about this port, so let me stop here, and this will be the end of this episode. But in next episode, I will talk more about this report and go further through the findings in this report and let's say share with you my thoughts about the findings. Thank you very much. See you next week.
Thank you for listening to this episode of DevOps in Agile Way podcast with your host, Pavel Pivac. Subscribe, comment, and do not forget to check our next episodes. Stay tuned. Stay safe. Stay curious.